Welcome to Banks and Markets. This is Binam, and in this video I'm going to talk about geometric mean and arithmetic mean. So it is the discussion related to different measurement techniques of return. So in my earlier video we talked about how we can derive holding period yield and geometric mean. So let us now talk about arithmetic mean and geometric mean. Firstly, let us take an example of return on investment for an amount of, let's say, 100, okay, 100 over 2 years, and let us assume that in the first year it went really bad, therefore we recorded a negative 50%, and in the second year it turned out to be good, and therefore let us assume the return was 50%. So arithmetic average will simply tell us to add these two together and then divide by the number, which is 2. So we get 0%. But this gives a wrong impression that the investor is breaking even, okay, because the loss is only 0. However, if we look closely, then it's a different picture, because 100 this money, 50% lost means the remaining is only 50. And then if in another year there is 50% gain on this 50 amount, that means the gain is 25, therefore 50 plus 25. The end value of investment is therefore 75. So it is, the end value is not 100 to say there is no profit, no loss. The end value is actually 75. So the arithmetic average is giving a wrong impression. So what we therefore can do is find out the geometric mean, for which what we need is 1 plus r, which is 1 plus this rate, okay, equal 1 plus minus 50%, and again the same for here, okay. So this then basically means if we start applying it for this investment amount, we get 50 here, and for this amount when we apply the figure, then we will be getting 75. So this is the end value of the investment, this is the beginning value of the investment. So therefore the end value of the investment 75 divided by the beginning value of the investment, we get 0.75. Now this 0.75 is 2 years, so therefore 1 over 2 take away 1 gives us the rate of return, which is roughly 13.40%. So this is the actual rate of return. So in order to obtain this, what we have done is basically the procedure of geometric mean. And what we have seen here is, in the geometric mean, what we need is 1 plus r1, 1 plus r2, all the way to 1 plus rn, and the power 1 over number of period, take away 1. This is what we need. So the arithmetic average, which is this, is simply additive, but the geometric mean is multiplicative because we find 1 plus r1, 1 plus r2, and so on. The geometric mean by definition is always lower than the arithmetic mean due to compounding effect, okay, whereas the arithmetic mean is always higher than the geometric mean, mainly because it is a simple average. So what we will do now is we may like to see the formula. To those of you who are new to this, it may be good that you know that the formula. So formula geometric mean. So we should find something in the image, and if there's a comparison geometric and arithmetic, that's the one. We can see, so that's the one. Arithmetic mean, additive, geometric mean, multiplicative. Okay, so with this in mind, now we can find out the arithmetic mean first, and then compare the two for this data set, which was discussed in the earlier video. So arithmetic mean here is going to be equal average of all these returns, and annualized arithmetic mean is simply 1 plus the periodic rate of return power this is weekly, therefore 52 take away 1, and therefore we get 3.343. Of course, the annualized arithmetic mean at 3.343 is higher than the geometric mean, which is 3.342. Now, given that these rate of returns they're similar to each other, this basically means there is no big outliers. So therefore, these returns given by geometric mean and arithmetic mean are not far away from each other. But if we change, and let's change in week 11, let's say we get something like 0.99, then you will see that the difference now is bigger, 7.250 and 7.272 arithmetic mean and geometric mean, both for the weekly and the annualized. So when we have these types of returns, and also the returns which is correlated with other returns such as the benchmark return, it's always good to apply geometric mean, and is also the reason why geometric mean is more popular within investment and finance. So what we will do now is look into the cumulative return. Okay, so cumulative return, and this is basically simply the summation of all the returns for each period. So it is simply to say by how much the money will grow at the end. So that's what we're saying. 1 million will become 1,600,978, and that's something that we can find from the cumulative return figure. Okay, so we'll be continuing our discussion, and in the next video we'll talk about the use of log returns to find out the return again. Okay, so thank you very much for listening.